folks, use the facility, get a cup of coffee. If you need to get up and get a cup of coffee, please do so. For those of you who don't know me, I'm Ted Benning of Benning Construction Company, and I want to congratulate each of you for being here on a Saturday morning to improve yourself and to work on becoming better at what you do at Benning Construction Company. It shows a strength of character and dedication to your jobs that many of your peers have not shown. And also to the folks up in Virginia, thank you for being online and listening and seeing if we can learn something together. Let's see, is this working, Darcy?
Yes, it should be. Yes, sir.
Okay. Now we're going to be talking about a few things, a few concepts to start with. And it's my belief that we start with concepts which are expressed in words. And those concepts form the foundation, just like we put a foundation in a building in which we build a structure of knowledge. Okay? So, Tyler, if you would read that to us.
All right. Arithmetic teaches us the power and properties of numbers, which are variously affected by letters, tables, figures, and instruments. By this art, reasons and demonstrations are given for finding out certain numbers whose relations of affinity to another is already known or discovered. The greater advancement we make in mathematical sciences, the more capable we shall be of considering such things as ordinary objects of our conceptions, and be thereby led to a more comprehensive knowledge of our great Creator and the works of the creation.
Okay? So there's a purpose for arithmetic. One of the first men that I worked with in the field was a fellow named Frey Hayes. Frey Hayes had a 6th grade education. He was a superintendent for Benning Construction Company. He had learned everything that he knew through trial and error. He had self-educated himself and had elevated himself even though he had a 6th grade education. So the level of education that you come into this class means absolutely nothing. Because if Frey Hayes, coming from his humble background, could learn to be a superintendent at Benning Construction Company, anybody can. And so we start with arithmetic, adding, subtracting, multiplying, and dividing, the 4 key elements of arithmetic. Now, we then move to geometry. Lisa, you want to try that?
Geometry teaches of the powers and properties of magnitudes in general, when length, breadth, and thickness are considered from a point to a line, from a line to a surface, and from a surface to a solid. A point is a dimensionless figure and an invisible part of space. A line is a point continued and a figure of one capacity, namely length. A surface is a figure of 2 dimensions, namely length and breadth, and the solid is a figure of 3 dimensions, namely length and breadth and thickness.
Okay. Now, geometry is where we begin to apply the concepts of arithmetic. Now that, most of us when we hit geometry, most of us hit that either in late grammar school or early high school, and it was generally taught and it was somewhat confusing, at least it was for me to start with. But I'd like to start with some fairly basic things here about geometry that I think are important because we'll use these as we go through our examples. Now, what we're trying to teach you in this class is a system. Okay, what is a system? Miguel?
It's like a group of things that make
It's how something works.
Right.
Right. So a system, if we take a look at our vehicles, we have a braking system. Okay? How does a braking system work? We have an electrical system. How does that system work? In geometry, we also have systems, and that system begins with the first thing, which is called a what. Let's go for our late breath from a third line, third word. What's that word?
Point.
Point. What is a point? Get your pads out, put a point on. Just draw a point. Okay? Now, if we connect 2 points, draw another point, what do we have? A line. Okay? So from a point to a point is a line, right? We're doing batterboards and layout. If we're laying out a wall, what's the first thing we do? We establish a point of beginning. We establish a point of beginning. We then measure from that point of beginning to another point to establish a line. Now that line can be a piece of string, it can be a laser line, it can be virtually anything, be a chalk box where you snap a line on the ground, but it forms a line. So the first concept I want us to get to this morning is that of a point and that of a line. Okay? Is everybody up with me?
Yes, sir.
Mr. Don Rosario, are you up to speed on that?
Yes, sir.
Very good, very good. Okay, now, we go from a point to a line, and from a line to a surface. Now, what is a surface? Surface is anything which is flat. You can have curved surfaces and flat surfaces, but for what we're talking about right now, a surface is something which is flat, okay? So if we were to put this in an isometric, let's see if I can draw that. Sorry, somewhat sketchy drawing. We have a surface. What is unique about surfaces? What do surfaces have which lines don't?
Area.
Very good. So, we know that lines are linear, L-I-N-E-A-R, okay? And surfaces are area, okay? So we go from a line to a surface, and when we add our third axis, it becomes a block. And the block has what?
Volume.
Volume or capacity, okay? So a solid has volume. Okay? So as we go to the fifth line, a line is a point continued in a figure of one capacity. Okay? That's called linear or length. Okay? A surface is a figure of two dimensions, namely length and breadth, okay? Which is, we've all heard length times width equals area. And a solid is a figure of three dimensions, namely length, breadth, and thickness, which gives us volume. Okay, any questions about what we've gone over so far? Okay. Why numbers, why lines, why geometry? Okay, somebody read that for us.
By this, the advantages of geometry. By this science, the architect is enabled to construct his plans and execute his designs. The general to arrange his soldiers. The geographer to give us the dimensions of the world and all things therein contained. To delineate the extent of the seas and specify the divisions of the empires, kingdoms, and provinces. By it also the astronomers are enabled to make his observations and to fix the duration of time and seasons, years, and cycles. And fine geometry is the foundation of architecture and the roof of mathematics.
Okay. So when you look at a set of plans and specifications, our architects have taken geometry and they've taken a concept of words. I'd like to have a public supermarket. You know, I'd like for that public supermarket to have a deli department. I'd like for it to have a meat department or whatever is in that particular building. And through the use of words in geometry, the architect attempts to capture the desires of the owner and to put that in a pictorial form using geometry. And so as we learn geometry, we learn that construction is full of numbers. It's full of numbers. You cannot stay in construction very long and understand that it's not full of numbers. So what do we do with all those numbers? Well, today's class is here to try to help us get some of the fundamentals of those things. Okay, some of those fundamentals of those things. Now, on your desk, you've got a basic test.
We actually have two of them, so
Yeah,
don't,
only do one of them.
don't
Only
be
do one.
concerned.
Okay. Now, I want to make a point here. We're here today to learn. Okay. I am not grading your tests. Okay. Darcy's not going to grade your tests. These tests are for you. You're here because you want to improve yourself. And if you need somebody like me to go behind you to encourage you, boy, you are really, really in a bad place. Okay. Motivation has to come from the heart. It has to come from within. And the fact that you're here indicates that. So we're going to take the next 20 minutes. I want you to get as far as you can in 20 minutes. And get started on the top. You can use calculators, use pencils, papers, but, oh Lord, but do not, under any circumstances, do not under any circumstances cheat with your paper.